tested on everything you do?
Different for the university, but no, it depends on the university. But most universities, no, mostly coursework and semester exams.
Oh, so after the semester exams they don't mention
Most places, most. Not all though.
Just NUIG, one of them.
Try to ignore him. And is the projector on, please?
Rock, paper, scissors.
Projector. After that donut, you should have plenty of energy to turn the projector on. It's a good donut, huh? This is payback for your advice. Your advice. Maybe you should keep your advice to yourself. Alright, what did I say? Physics first, okay. Beyonce? Really? Rihanna? Yeah. Ridiculous. Sorry, I knew that.
I'll show you something.
No, please.
No.
Please.
She started dating a Saudi guy.
Did you hear about that?
She does.
Yeah.
He's Saudi.
Like
Proper Saudi.
And he's one of the richest, richest.
She doesn't care about his money. She has
I think
problems.
she has enough money. Yeah.
1.5 billion.
What's the family?
Okay, she has 2.5 million. It's fine. She don't need. If you have a million, you don't need a billion.
Of course you do.
Look.
You think
What's the family name?
The family name because what is your
That's stitched together. Yeah, I thought so. Yeah.
His family is not worth.
Guys, come on, pen and paper. Can we try these questions now? I don't think I need to do all of them, but I'll tell you which ones to try now. Can you write these numbers down?
Yeah, Jamil.
Can you start with number 4, please? How many of those do you have?
Now one.
Now one. No, thank you. One and a donut is enough for me today.
I feel sorry.
Ah, Fawar, don't feel sorry for that guy. Dude, be cool. Is that the one that you dropped earlier today on the street? You were telling me about.
Yeah.
What?
Enjoy. Just open it before we take some bite.
Oh yeah. I thought that was a plain vanilla one. Why is it all brown? Continuing. Right. Can you start with number 4, please? I'm giving you my lunch hour here to do an extra class. Start at 4. I'm going to do these, then I'm going to do your questions. If you're good, will you be a good boy today? Thank you. And you have all the details, the information down here for the questions you may need.
gravitational pull strength is the small g.
Yes.
Start from 4.
For the 10th time, yes. Start from 4. And then go on to 5. Don't go backwards to 3. Just to be clear. Do some physics and burn it off then. That kinetic energy for moving the pen has to come from somewhere. Please turn the music off.
It's playing.
Dude, you're deaf. Shall we take turns? Are we nearly finished number 4? No, not yet. Okay. Oh yeah, number 4 actually is a little bit long. There's actually a bit to do in number 4.
Isn't it g over r squared?
Yeah, that's r squared 1, yeah.
If you make F0 from
But do you make F0?
1,
No. The total force is 0. This means the pull from the Earth and the pull from the Moon are equal. So make these two forces equal. Then the total is 0.
Oh,
oh, okay.
Yeah, what I understood was when the gravitational is the spaceship is too far for the Earth or the Moon gravity to act on it.
But they always act on it, no
Yeah,
matter how far away they are.
You are telling me that Pluto right now has a gravitational field that's acting on me?
Yes.
Pluto, bro. Do they still count it as a
No.
like a too small to hang out with us?
Yeah, no losers. Take a hike, Pluto.
But it's like, I'm too cool. I'm making good fun master.
Steven, you said yes.
To what?
Pluto acting on us.
Yes.
Yeah.
Yeah.
Everything on Earth, everything in the universe has that has a mass, has a gravitational field that's pulling you towards it, and you have the opposite field that's pulling it towards you. But because it's so far away, or it's heavy or not heavy, then you do not feel it. But right now, things from all around you are pulling you apart, but they're not strong enough to.
It does. It is true that there is a mass. The force is pulling on us, but you should also note that it actually does take time for the force to reach. So the weird thing is that the gravity force travels through space at the speed of light. So it means that if you don't see it, it means there hasn't been enough time to pass for the light to get to you. So then you don't feel the force. So in other words, you only feel gravitational force of the things you see in space. Because if you can see it, it means enough time has passed that it's made it to you.
So
Sounds very logical.
did we
It
see
does.
Pluto?
Yes.
What?
Yes. You can see it in a telescope.
What? A what?
Pluto.
Yeah.
Can you look for it?
Yes. Did you get an answer? No. You're unhappy with it?
Yeah.
Yeah. Why unhappy?
I don't know because I can't do anything.
Okay. No. That's harsh. Can't do anything. Will we have a look at 4 now? Yes. Did anyone get it? Lee?
Oh, question 4 is so heavy.
Because
Ah,
Lee-
it's pulling me. Ah.
I don't know, are you having like a fit or something? Can you just tone it back a bit, please? Right, 4. Lee!
There's a gun.
Did you do number 4? Did anybody get number 4? Okay, I should point out number 4 was an exam question 2 years ago. So what we have here, Earth, Moon, distance, and we wanted where the place where the force is 0. So that means the force here should equal the force here. And we'll call this mass ME, and we'll call this mass MM, and we'll call this mass M. So the force to the left will equal G ME M over R squared, and we'll call this distance here R. This distance here, we'll call it big R minus small r, where big R is the distance between the Earth and the Moon, which we know. G M over R minus R squared. So that means G M over R squared equals G M over R minus R squared. What can I cancel? G M. Yeah. And I'll do a little bit of a rearranging. I'll say ME over square root equals R over R minus R. So let's calculate this. Mass of the Earth divided by mass of the Moon square root. So can you just do this number? No, mass of the Earth. Yeah, this divided by this square rooted. Earth divided by Moon square root the answer, please.
.02.
9.02. So after the root?
Yeah.
9.02 equals R over R minus R. So that means 9.02 R minus 9.02 R equals R. So 9.02 equals 10.02 R. So I just take this to the right and add it to one of those. So finally, small r is 9.02 divided by 10.02 big R. In other words, roughly 9/10 of the radius is where you need to be for the forces to cancel. So if you just do roughly 0.9 R. So if I look here, distance between the Moon and the Earth is that. So if I just reduce that by about 10%, it's about 300, roughly 340,000 kilometers. You can hit this in on the calculator if you want it exact, but it's about 340.
This was the 2015 paper.
You saw it in there? Yeah.
What's the big R?
The distance between the Earth and the Moon. Yeah.
2 months.
Now, how many marks are going for that Faisal if you have the paper open?
I think like
Now, before you say it, let's just see what the class think. How many marks do you think, guys? You going with 4, okay? 5. Thank you. Fuang has the exact answer. 347.
6.
6 marks. Bros. What do you think of that now?
Nice.
If you can do it. Yusuf, what was the problem for you?
I wanted to like put F, like the force on the right and the force on the left one on one side of the formula and like.
Oh yeah, harder, huh? So you had it like left minus right equals 0. Yes. Actually, yeah. That would work, but just harder, yeah. Okay, can we continue now? Yes, did you write this down? Okay, so let's have a look at the next one. The next one is, what is the gravitational field strength due to the Earth on a plane which is 10 kilometers above the surface of the Earth? So there's the one formula you have for this, just.
Did they break down that function or did they just do it?
No, well, did they? I don't think they did. They just said, what is the distance? You have an answer?
Just a second.
Okay.
6, square. 9.78.
Yep, that sounds about right. It should be less than 9.81 because of the higher altitude. You got 9.7. Okay. Yes.
7.9.
Look.
7.9.
7.85. So if you're on
No, it's not 5.
9.78591.
I got 9.779.
Okay, خلاص, you're right, I'm wrong.
If I was to bet money on it, this is how I would bet.
I used the G constant.
Ah.
Yeah, that's right. But I mean, we're both right.
Don't say that, it'll go to his head.
We're both right.
Yes. Huh?
9.97. 9.78. Yeah.
What did you get?
I can see her answer here and it's huge.
No, I'm wrong.
Did you? It's kilometers.
I'll tell you what's
So,
R
you
squared.
use
What's your value for R squared? You
6,000.
put that 10 kilometers over.
Show me.
You need to add the radius of the Earth.
That's fine.
Add.
No,
Add.
it's above.
The plane is 10 kilometers above the ground, not 10 kilometers below the ground. Yes.
What's the 10 kilometers?
Added to the radius, the plane is above the Earth. So it's or plus 10.
I thought only that one.
Only 10? Oh no, that means it's in the center of the Earth, 10 kilometers from the center. Hot journey.
What's the unit?
For what?
Gravitational field.
You tell me. We had it earlier today.
Newton meters.
Oh no, it starts off well. Newtons per kilogram.
So also multiply
Huh?
that.
Multiply what?
The 10 in the radius of the Earth.
Look, if
The
you're
formula. Do you know the formula? It's gm over r squared.
the R square. You don't multiply. If you're on the surface, you use the radius. If you're 10 meters above the surface,
Yeah.
what do you do?
Radius plus 10. Yeah?
Plus?
Yeah, plus 10. Fawn, here, look. You should use... Here, where's my pen gone? Here. You should use, go away. 6381000. Yeah?
Yes.
So what the answer?
9.79 or something, yeah. Okay, I don't, yeah, we don't need to do 6 because it's kind of the same thing. So, the juicy one. No, I'll do something, I'll do some extra question, which is like 7.
What's with
No, you'll like it, trust me, you'll like it.
I didn't finish reading it.
No, but I'm going to do something very similar to it. So it's the
But
same
I
thing.
don't want you to help us to do it.
Yes.
No, I'm not doing number 7, I'm doing my own thing now.
As it relates to 7.
Yes,
No, that's the
No,
thing.
yeah.
but it's too advanced for you, what I'm about to do.
Challenge me.
Yes. Challenge us.
Okay. No, I think you might be able to get it. Alright, here's the problem.
No, don't explain it. Don't.
No, I mean,
just
I don't
give
mean,
it to us.
yeah, I'll just give you the information to do the question, right. You have,
Throw. No, you're ruining it.
Nothing. That's help. We don't
it's
want
not help, it's easier for me than to write words. I'll give you minimum. Mass, radius, rocket. Rocket fire. I'm not using too many words, am I? What? What? Are you criticizing how my rocket looks?
Obviously.
Rocket.
Big rocket.
Now, this is fired away. Okay. So, the question, and it's fired, it has a speed v. And my question is, what is v?
Okay, go back here. Thank you.
Now, in this question I said for Earth, but it doesn't really matter what planet it's for. You can just use m for mass and or for radius. It's not really important. But I'd prefer you to keep it general. Use letters. Mass m, radius or, and v. Now I give you a hint in the question, and I'll give you the same hint in this one. The hint is, when the rocket is free, its kinetic energy is equal to 0. And its potential energy is equal to 0. Because it's not really moving, it's just kind of drifting slowly. And it's not trapped by the Earth or the planet anymore. So both energies should be 0 when it's free. And that's the hint to get you started. See what you come up with.
Control Alt.
Control Tab, in fact.
Alt tab.
Alt Tab. Yes, Alt Tab. There you go. Then after this we'll have a look at, how many questions do you have?
2 maybe. You want a value.
Well, in terms of M and R, yeah. And, yeah, what's the V? How are we doing on this?
So we don't need any mass.
Yeah, you can just keep it as m, please, in your answer. You don't have to put numbers in. Yeah. Yeah. Not giving it a try, Andrew?
I was thinking of it differently. Very,
You-
very different.
You're so stoked about Galway that,
No, it's just
wow.
that if you go back to the question,
Yes.
the engine is about to be cut off. How fast does the rocket need to be traveling at so it can escape the pull
Yeah.
of the Earth?
Yeah.
Can.
Well, we sent rockets into space, so we can.
But you said that it will always be affected
Correct.
by it. So it
Correct.
will always be affected by the pull.
Correct. And how successful is Pluto at pulling you back to Pluto?
Not at all.
Exactly.
But I'm never going to escape that pull.
Well, I don't know, if you're on Pluto, I think you can get a rocket
No,
powerful
no,
enough
no.
to go back to Earth.
You're thinking about this too much.
Well, no, I wouldn't say that. You're thinking about it the wrong way. When the rocket is in orbit of the Earth, the force is still there from the Earth. If the rocket is going fast enough, this force can be used to form a circular motion force and orbit the Earth instead of falling back in. No?
Can you say that slowly?
Yes. When the rocket is in
Gently.
when the rocket has left the Earth, the force is still present. If the rocket sets its direction to travel around the Earth, it can use that force from the Earth as a circular motion force acting towards the centre of the Earth and keep it in orbit. The force hasn't gone. In fact, the force is what keeps it moving in a circle.
Okay, so what distance does it need to be?
Yeah, to escape, so that it doesn't actually get trapped in an orbit. In other words, we're trying to ionize the rocket, have it escape the Earth.
Yeah, to not be pulled.
Yeah.
Okay. I thought to not
I
be
placed
pulled.
an answer.
Ah. You what?
I placed an answer.
What is it?
V equals root minus 2 GM over R.
That could be it. I don't know exactly calculate, but I think you
I think I have something similar.
basically
But I have numbers.
the energy at the end is 0.
Yeah, so you equate them.
So that means the energy at the start is 0.
So have mv squared equals mgh.
Oh, it started off so well.
B squared equals to the potential energy.
Yeah.
Equals minus GM M
Yes.
over R. Yeah, that's
Yeah,
what
but then can you substitute the value of
that's what I wasn't
Only
sure
R.
about.
I
M
can't
over
use
R?
mgh?
No.
No, because that's only when it's on the surface, which
Yeah.
is where we don't want it to be.
This is where I got confused.
Yeah.
Which M do we cancel?
The N normal.
One
Big-
of them.
No, one of them is for the rocket.
Yeah,
and
yeah,
the
so
other
which
is
one?
For the Earth.
The rocket will say small and the Earth is
Yeah.
big.
Yeah, so we cancel the small one.
Yeah.
So
We
the-
don't-
the velocity of the
Yeah.
yes, okay, correct.
So we get v squared equals 2 gm
over R.
over r.
So V equals root.
Yeah, yeah.
Yeah,
Now,
uh,
but
What
wait,
about
wait.
the minus?
Now the minus I already considered because it was really this kinetic energy plus potential energy.
equals-
That's the total energy, which equals 0. So this was a half mv squared plus minus gmm over r. So then I took it to the other side and the minus is gone.
I don't know. I thought it was all-
Now,
I was thinking that-
interesting.
but then-
yeah.
What is the relationship between the velocity required to escape and the mass of the planet?
More mass, more velocity.
More mass, more velocity. And the radius?
More radius
Yeah.
and velocity.
Less velocity. Okay.
But
Yeah.
can we put the value of the mass of the Earth?
I'm getting so frustrated with people not listening to me. I
listened to you.
Oh, okay. Oh, you're okay.
I thought you were talking about the rocket.
Are you asking, can you, or can I please do that so you can see the numbers?
No, like.
Make this good now. My patience is disappearing.
You said.
Yes?
You said the mass is like you shouldn't consider the mass. I thought you were talking about the mass of the rocket. Like
What?
put M for mass.
Yeah,
of
which
the
I
rocket.
did.
Yeah. Do we need to put?
No, he wants a general formula.
Yeah.
Oh.
Yes.
Okay, now I have a question.
No, I was in the middle
Okay,
of
sorry.
explaining something. Can I continue, please? Now, as I was saying, bigger planet means faster rocket is required. Make sense?
Yeah.
Why do you think a bigger radius means you need a slower rocket? Well, if the radius is bigger but the mass is the same, the force is less because you're further away from the center. This all makes sense. So let's see. Let's look at it the other way around. Let's see what must the mass be, or what was the mass if the velocity was v squared or over 2g. So if I tell you the escape velocity is blah 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 for a planet with a particular radius, you can tell me what the mass of the planet must have been, right? Okay. Now, what happens if I do this? What am I saying?
Speed of light?
That if an object is traveling at the speed of light, it must have a mass, which isn't possible.
Yeah. So, what does this mass represent? It's the mass of a body whereby to escape the body you need to be going at the speed of light or greater.
Again?
This formula is for mass of a body that requires you to be going faster than light to escape.
Escape what?
The body, the planet. This planet. You would need to be going faster than the speed of light to escape it. Now I'll give you a hint. If you have to be going faster than the speed of light to escape it, then that means no. Listen. If you have to go faster than the speed of light to escape this planet, then that means light cannot escape this planet, which means you can't see this planet. It means this planet is dark. Huh? No? Close. This planet is dark. In fact, you might even say this planet is black. So, if you have enough mass, the planet is no longer a planet. Well, I mean, it's still a planet, but it's become dark and you can't escape it once you land on it. This is exactly what a black hole is.
Is it?
Yes. And this is the formula to calculate the mass.
So the black hole is like a planet.
Yes.
People can live on it.
Well, no. Now, wait. You could rearrange this to get R equals 2gm over c squared. So what happens when you get a black hole is that you have a star. How do you get a black hole? You have a star. The star at the end of its life starts to shrink. Does its mass change? Not really. It's just getting denser. Density. So this stays the same. This is decreasing. At some point you will get this relationship. When this relationship happens, you have a black hole. So let's imagine we could shrink the Earth down. It starts to shrink. At some point it becomes a black hole. I'd like you to calculate that. You know the mass of the Earth. You know the G, and I'll remind you of the C. It's 3 times 10 to the 8. Calculate what you would have to compress the Earth down to form a black hole.
How often does this happen in reality?
Of what? It doesn't happen for planets, but it happens for suns. I don't know the exact number. I would
We
imagine.
only know about 3, 4 black holes?
Well, that are near us.
Yeah, that we can
Detect.
detect.
But of course,
So
since it's black
you can't
and the
see
sky
it.
is black,
Yeah,
kind of hard to find them.
dark matter.
8.85 times 10 minus 3.
Yeah, so that's roughly a centimeter. No, that's roughly, centimeter. It's 8.8 millimeters.
Yeah.
So, take planet Earth, shrink it down to 1 centimeter, and you've formed a black hole.
Get me Earth or something.
Yes.
Their hands.
Anything that is now on the new Earth, Earth 0, can't escape. Because it would need to be going faster than light.
Bad. So a black hole,
Yes.
originally,
Yes.
was a star or a planet.
Yes.
How huge was it?
We can work it out from this formula.
But like the size was.
Yes, huge compared to what it will be. Because, for example, the Earth,
Earth
what
is
was
1
it, 6,000 kilometers?
Yeah, around.
Compress it down to 1 centimeter.
Oh.
So the same proportion for stars.
Wait, so there's a surface on the black hole.
Yeah, there
So
is.
you don't just get sucked into.
Well, you will get destroyed into billions of atoms and then get sucked in. They'll tear you apart. Yeah. The question of it doesn't really matter if there's a surface or not. You will be torn to pieces before you reach it by the force of gravity. And what will happen is, as you approach the black hole, you'll pass a point at which you can't return because you'll need to be going faster than light. And then you start to approach the surface of the black hole. The force is so great, it will tear you into billions of atoms individually. There'll be no more Yahya. And you will be spread across the surface of the black hole, left to spin on it in dust for a few million years.
What is the theory about the time travel? So let's say that.
Time travel is if you're near the black hole.
Near.
Do not enter. You will not come back out. It's a one-way journey.
Like,
If you are very lucky, maybe you'll come out from a white hole. If you are very lucky.
what do you want?
They're the opposite.
So they're trying.
You're
Yeah.
living in denial.
I heard that example.
They probably don't exist because they would be quite easy to see
Yeah,
since they would be
sure.
bright and glowing. Because they're literally the opposite.
Maybe they're just so far away.
Yeah, but
Do you believe in aliens?
I believe in Superman.
yes, I believe in Superman.
No,
and
but
he's
like,
an alien,
there-
so
there-
I guess
there-
so.
There's this song, and then he goes like, our.
Oh, we told them about the pillow talking.
Yeah. He goes like our ever opposite of infinite. No.
Finite.
No, it's infinite. Our infinite galaxy, our ever expanding
Yes.
galaxy. I think we're the only species that exist on this planet Earth. That's what it goes like. If you think about it, like there are so many other galaxies that are so far away that we have no idea about.
But we can only act off of our evidence, and we have no evidence of any other life.
But what if there is another Earth in one of those galaxies right next to us?
Yes,
And they're so more advanced than we are.
yes.
And they look at us every day and laugh. They're like, hey, look at those stupid guys over there.
You can see each other and teach them.
And then telling them we don't exist.
That would be funny. Yes.
They're
Yes.
probably laughing at ourselves because we think it's such a stupid
Yeah.
idea.
But now, to blow your mind, what if we are the smart ones?
Yeah, I thought about this too.
That's very stupid.
And we can go and teach them things. Teach them how to reproduce. I volunteer. There's this meme.
No, please.
No.
Stop. For
No,
goodness sake.
wait. It's
What?
it's a picture of a girl in a jungle.
Yeah.
And then it goes like, you see this girl in the jungle. What will you call your son?
I don't get it.
It's very dark. It's very dark. It's easier to get
See a girl around in the jungle. What will you name your son?
I'm not getting
She's
it.
alone, she's vulnerable, she has no one to protect her.
And she's in a jungle.
I don't get it.
You are making your son right there.
No, I
Here,
think
Yeah.
ETAR.
Pronounce that backwards.
Dude, it's not cool.
It's not.
That's what I said.
She's the last human existing. You have to save this. You have to save our species.
You just tell me how your therapy goes after you finish here.
I'm naming him Galactus.
Oh, I must have done something. Wrong. There must be past lives. There must be. I must have done something really bad in the past life to be a physics teacher for this class. Like, I must have been killed 10 people in my last life, and this is my karma punishment now.
For each one.
Yeah.
What?
You're so innocent. This is only level 1.
Yeah.
I'm still behaving like you're a teacher.
Well, what was the denominator?
It was.
Oh.
Yeah. Now, Faisal, what are those questions? Let's have a look at those. And then,
There are people outside there.
I think they are.
I thought we had a class in here too.
No.
Oh, rats, really?
Yeah.
What's
No, don't say that.
B41.
B3.
DIFC student?
B301.
Yeah.
There's a hub there.
Medicine student?
Oh, flip. I thought we were here for
But
2 hours.
Who would they have a class with?
Yeah, because Lorraine's not here. Maybe I can get rid of them. Oh, bio! Yeah.
No. Steven, go out to them, shoot, and come back in.
So nice and vulnerable. Welcome to the other number.
Be harassing.
And
I mean, do you know initially I did the presentation on black hole.
How big is the black hole? The area?
this is the main information that we told us start from the beginning.
Today's Chino was talking about in his presentation. Oh,
Let's
here.
move. Well, you know, use, I think D213 might be great. Because this is my logic. You can use those. Yeah, you can come in,
What is it?
Can't you? No, because they're for language class. We'll just use D213. It's fine.
I'll just go to B.
No, because then I have to get a projector.
Why can't they just go there?
Because technically they have this room now. We're the intruders. We're the invaders.